In 1940, the third longest suspension bridge in the world collapsed in winds of 42 miles per hour. The bridge, which cost $6.4 million to build, had been open for only 4 months. It didn't collapse because of the gentle wind, but because the government agency decided that a safe bridge was too expensive to build, while a cheaper one was just as good enough. And when it finally collapsed, only a dog named Tubby lost its life. This is the story of how a stronger design for a bridge was rejected to save $4.6 million, how a famous bridge engineer replaced the bridge's steel trusses with thin plates, and how engineers dismissed the warning signs, believing a dancing bridge was safe. In the late 1930s, Tacoma was a growing city with about 109,000 residents. But getting there was really difficult. The only option to get there was with a ferry, which was always slow, crowded, and often delayed by bad weather. So for years, people wanted a bridge to ease the travel. Then, in 1937, the Washington State Legislature created the Washington Toll Bridge Authority to build a bridge across the Tacoma Narrows. The authority then hired a state engineer named Clark Eldridge to design the bridge. Eldridge knew the Narrows very well. The winds there regularly reached 40 miles per hour, with stronger gusts going much higher, so he designed a bridge built to handle them. His design used deep, open steel trusses that allowed the wind to pass through instead of pushing against the bridge. It was conventional, proven, and most importantly, it was strong. But the design was expensive. Eldridge estimated the cost to be around $11 million. The federal agency funding the project didn't want to spend that much, so they told the state to find a cheaper design, and that's where the story took a turn. The man they found was one of the most famous suspension bridge designers in America. His name was Leon Moisseiff. At 66, he was one of America's most respected bridge engineers. He had worked on the Manhattan Bridge and consulted on the George Washington and Golden Gate bridges. So when Moisseiff proposed a cheaper way to build the Tacoma Narrows Bridge, the agency listened. His idea was that a suspension bridge didn't need massive steel trusses to stay stable because the cables and the weight of the roadway could do much of the work. He called this idea the deflection theory. Eldridge had originally designed a 25-foot deep open trusses, but Moisseiff replaced them with 8-foot deep solid steel girders. Think of an open truss like a chain link fence. When the wind blows, it passes through the gaps in the truss. A solid girder is more like a billboard. When the wind hits it, it pushes against the entire surface. And that's exactly what Moisseiff had put along the entire 2,800-foot bridge. The result was a much thinner bridge, and more importantly, it was much cheaper. Moisseiff's new design brought the estimated cost down from $11 million to $6.5 million. But Clark Eldridge wasn't convinced. When he saw the new design, he called it an unreal plan, because he believed the solid girders would make the bridge much more vulnerable to the strong winds in the Narrows. Eldridge was a state engineer, while Moisseiff was a nationally respected bridge engineer. So the Public Works Administration decided to approve Moisseiff's plan because it was cheaper than Eldridge's plan. Then, in 1938, the construction for the Tacoma Bridge began. 2 years later, on July 1st, 1940, the Tacoma Narrows Bridge officially opened, and on that day, something strange happened. The bridge moved. The roadway rose and fell in vertical waves, sometimes by as much as 5 feet, whenever the wind went above 20 miles per hour. Drivers could watch the car ahead of them disappear below a wave, then reappear moments later. It was surprising. Some people even drove across just to experience it. Soon, the bridge got a nickname, Galloping Gertie, due to its wavy movements when cars were passing. The movement was a serious engineering problem, and the bridge was far more flexible than anyone had expected. The problem was that Moisseiff's deflection theory had never been tested on a bridge this long, narrow, and light. The theory worked with forces like gravity, the weight of traffic, and direct wind pressure, which engineers already understood. But it didn't account for what happens when wind interacts with a flexible structure, and that was exactly what was happening to the Tacoma Narrows Bridge. So the Washington Toll Bridge Authority brought in Professor Frederick Burt Farquharson from the University of Washington to study the problem. Farquharson recommended installing hydraulic dampers to reduce the movement. The hydraulic dampers were installed, but the wind tore them loose. He then recommended adding steel cables to help control the movement. These were installed too, but they still didn't work. A third solution was proposed: additional cables connecting the bridge deck to anchors on the shore. That project was approved, but it was never completed. By then, the bridge had been moving for 4 months. Everyone could clearly see that there was a problem, yet the bridge remained open. Thousands of cars continued to cross it every week. Some drivers avoided the bridge, while others crossed it just for the experience. It even became a local attraction, but nobody closed it for a full safety investigation. Then came November 7th, 1940. That day, something much worse was about to happen. At 7:30 a.m., the wind at the Tacoma Narrows reached 38 miles per hour. The bridge began its usual vertical movement, the same up and down motion drivers had become used to. But by 10 a.m., the wind had reached 42 miles per hour, and the bridge's movement suddenly changed. The bridge stopped bouncing up and down and started twisting. One side of the roadway rose, while the other side dropped. With every cycle, the twisting became worse. By 11 a.m., large sections of the roadway began tearing away from the cables. Minutes later, the 2,800-foot center span had collapsed into the Puget Sound. A bridge that took 19 months and $6.4 million to build was totally destroyed in less than an hour. The collapse was only the beginning, because now engineers had to figure out exactly why it happened. Leonard Coatsworth, an editor for the Tacoma News-Tribune, was the last person on the bridge. He was driving across with his daughter's Cocker Spaniel named Tubby when the bridge began to twist violently. Coatsworth managed to escape the car, but Tubby was trapped inside. When the bridge finally collapsed, Tubby went down with it. He was the only life that was lost. Clark Eldridge warned about the solid steel plates before the bridge was constructed. His original design used deep, open trusses that would have allowed the wind to pass through the bridge. But his design was rejected because it was more expensive. Leon Moisseiff, on the other hand, damaged his reputation since his cheaper design that was chosen failed. Weeks later, the federal government assembled a 3-man investigation team to find out more about the collapse. The team included Othmar Ammann, the engineer behind the George Washington Bridge, and Theodore von Karman, an aerodynamicist from Caltech. Their investigation discovered that the bridge had experienced a form of aeroelastic flutter. In simple terms, the bridge's movement changed how the wind acted on it, which made the movement even stronger. And the cycle continued until the bridge could no longer withstand it. The disaster changed bridge engineering forever. When the replacement for the Tacoma Narrows Bridge opened in 1950, it used the deep, open, stiffening trusses that Eldridge had originally proposed. Engineers also began taking wind effects much more seriously when designing long suspension bridges. Wind tunnel testing became an important part of bridge design, and bridge aerodynamics became its own field of study. The Tacoma Narrows Bridge didn't fail because of bad weather. A 42-mile-per-hour wind isn't a hurricane. It's just a strong wind that a properly designed bridge should be able to handle. The bridge failed because it wasn't designed for the forces it would actually face. Clark Eldridge designed for those forces. But Leon Moisseiff designed for a cheaper bridge, which the authorities chose because they wanted to save $4.6 million. Well, that decision eventually destroyed the $6.4 million bridge and made them spend another $8 million to build a new one. The Tacoma Narrows collapse became one of the most important lessons in modern bridge design. It was a lesson paid for in steel and in concrete.